Hey guys, welcome to my channel. I'm LeetCoder, and today we have an amazing problem for you guys, right? So this is a very good one. I'm pretty excited about it. So let's quickly go ahead and read the problem statement, guys, right? So they said that the question is called first bad version, right? Very good. So you're you're a product manager, right? And currently leading a team to develop a new product. Okay. Fortunately, the latest version of your product fails the quality check. Since each version is developed based on the previous version, all the previous versions after a bad version are also bad. Suppose you have n versions and you want to find out the first bad one, right? Which causes all the following ones to be bad. So you're given an API, bool, right, is bad version, which returns whether versions is bad, right? Implement a functions to find the first bad version. You should minimize the number of calls to the API. Okay, so we should minimize the number of calls. Okay, cool. So we're given n equals 5, right? Which gives us there are 5 versions, okay, based on what they said. And also giving, we will not be given a 4, right? The bad thing, right? So what we need to do, guys, but when they give us this range, right, find out which is the first bad version, right, by calling the API, okay? So they got 4 in this case, and for this one, n equals 1. There's one range, so this is bad, so we return 1 as the bad one, right? So yes. So there's probably different ways to solve this problem, guys, right? You can solve this problem by just doing a linear loop, right? A linear loop to just find the first bad version, right? Just loop through, uh, go from first version, right? Because we start from version 1 to version n, right? So that's our range that we need to take care of, right? Okay, so we do a linear loop to find that first bad version. So we checked, is one bad? Nope. It's 2 bad? Nope. It's 3 bad? Nope. It's 4 bad? Boom. We found the first bad. We return that, right? So this is O of n, right? So just pretty simple. But how can we do a little bit better, guys? How can we do better, guys? Right? So we can kind of let's kind of make sure that we see our range, guys. Right? Our range is like that, right? So let's say for this example, 2, 3, 4, 5, right? So this is our range, right? That we're doing, guys. Right? We need to loop and find the first bad version, guys, right? So this is our range. So we're giving a range, right? How can we take advantage of that, right? So in a way, the range is sorted, right? You can kind of see it, visualize it, right? It's sorted, right? So maybe we can kind of, make sure that we, optimize a little bit, right? Because we want to minimize the number of calls to the API, right? That's kind of important. You know what I'm saying? It's very important, right? So how can we do that, right? So maybe we can kind of use the fact that we have this API, right? This API can kind of tell us a lot of important things, right? A lot of good information, right? It can tell us if a version is bad or not, right? Maybe by using that, we can kind of help us in making certain decisions, right? Right. So let's say if I'm in a particular section um, where the version is not bad, right? Maybe I don't have to worry about, everything that comes before me, right? Or whatever, right? Also, if I'm in a partition in the array, right? Section of the array that the part is bad, right? I know that everything behind me is gonna be bad, right? I'm looking for the first one that's bad, right? So I'm gonna worry about things that comes before me, right? And that's where I'm gonna keep going, right? So that's kind of what I'm talking about, guys, right? So let's say for like this example, right? So by using those kind of questions, guys, we can kind of apply um binary search, guys, right? So we could apply binary search on this by not having to look and checking every single number, right? We can kind of discard half uh, of the range, right? By simply asking a question is if we're bad or not, right? If we're uh, bad, we can do it. So we can discard a particular range, right? By just asking our API a particular question, right? Because we don't have to brute force our way into just checking every single number. We can just efficiently and do it in a smart way where we can simply make the right decision, right, and discard half of the array at every time we call the API, right? But this way, we're minimizing the number of calls that we're making to API, right? So with this simple, our range is pretty simple. A middle element, right, would be this one, right? Okay, so our middle element is this, okay? And since our middle element is 3, right, we check, is 3 a bad version, right? Okay, 3 is not a bad version, right? So what does that tell you guys, right? if 3 is not a bad version, I know that nothing before 3 is going to be a bad version. So I don't need to worry about that fact, guys, right? See how efficient it becomes with better search, right? We say, all right, I'm not worried about you, the my left side, because you know I'm not a bad version, so I'm not worried about it. And then we go to our right, right? And we check. We do apply better search over that search space as well, right? We check. Is 4 a bad version, right? Yeah, 4 is a bad version. Okay. And then we cut down search space again, and then we return 4 as the answer, guys, right? This is how it would work. Okay. So let's say, for example, 1 is our bad version, right? Okay. How would this work? Right? Yeah, let's do the same thing, guys, right? The same logic. Think about it. Middle element will be 3 again, right? We say, is 3 a bad version, right? 3 is a bad version. Okay. So therefore, I don't need to worry about anything about onto the app that comes after 3, right? Because everything that comes after 3 is also going to be bad, right? Because 3 is a bad version. Okay. So now I'm going to focus my energy, right, on this range, right? Because that's where the bad version might exist, right? So I'm not gonna worry about my right side. I'm gonna focus on my left side and then apply better search on that, and then make decision, guys, right? And then you see, so we apply better search here again, guys, right? And then we check, is 1 a bad version, right? So 1's a bad version, right? That means I'm not even gonna worry anything on my right side, guys, right? So I'm gonna focus my energy here, all right? And then just like that, the left pointer will be pointing at the left version, guys, right? So just like that, right? So it works every time, every scenario that you can think of, right? So by asking those kind of questions, right, instead of brute forcing our way and checking every single number, right, we could just calculate the midpoint, check if is our midpoint a bad version, right, and then make a decision based on that answer, right? So if it's a bad version, right, I don't need to worry anything about my right side. I just continue to searching on my left side for the first occurrence of a bad version, right? So that's what, because I'm looking for the first one, right? So just like if I'm that bad, I don't need to worry anything on my left side. Just keep going to my right and I'll be good, guys, right? So it's kind of the mindset, the logic that I want you guys to understand, right? So the code is going to be relatively simple. So standard banner search. So a left, starting a lower bound, right, is 1, right? Because, it starts from 1, right? 1 version. And then the right boundary is n, right? Because, it goes up to n, right? And we have our while loop, right? Pretty standard banner search that we're doing here, guys. Is less than equal to target. We calculate our middle element, which is left. We're very comfortable with this now because we've done this many times, guys, right? So we calculate our midpoint, right? And we're going to be asking ourselves a series of questions, okay? What am I doing here? All right, so what are we going to do here, guys? What are we going to check? The API given to us, right? We just copy this. If it is a bad version. So if it's not a bad version, right? If it's not a bad version, we're going to update our left point to be mid plus 1, right? Because if I'm not a bad version, right, I know anything before me is not a bad version because I would have been a bad version if there were any occurrence of a bad version before me, right? So that's why I'm not wasting my time on the left side, right? I'm gonna go to the right, okay? And if it's the other case, the opposite case, we update we go to the right, right? If it's a bad version, because I'm looking for the first occurrence. Okay? Just like that, we can return the left, right? Okay, it looks good so far, guys. Let's press submit. Was it showing correctly? Let me zoom out real quick. All right, so you guys can see the code. Sorry about that. This is, like I said, a recap. We initialize our initial range. We do, which is from version 1 to version n, right? And then we have our while loop to apply pattern search. We calculate our midpoint and we check if it's not a bad version, right? We go to the left, we go to the right. And if it's a bad version, we go to the left because we're looking for first occurrence. Press submit. Awesome, guys. We're going to pass all the test cases, guys. So I want to thank you guys for taking the time to kind of watch the video, guys. If you guys found value, make sure to give me a like. If you're new here, subscribe because I'll be doing a lot of other videos just like this one. So I want to thank you guys for watching, and I'll see you guys in the next video.